So we've talked about how to specify combinational logic using assign statements. Now let's talk about how to specify sequential logic in SystemVerilog. SystemVerilog uses idioms to describe latches, flip-flops, and FSM. So these idioms are kind of formats that we use in SystemVerilog to specify, hey, this should be a latch, this should be a flip-flop, and we'll show you what those idioms are. Other coding styles may simulate correctly, but produce the incorrect hardware. So it's important to use these styles of idioms that we'll discuss right now. The general structure of specifying these latches and flip-flops is always at what's called a sensitivity list. So we put this always keyword at some sensitivity list, then perform a statement. So whenever anything in the sensitivity list changes, so when that event happens, the statement should be executed. So here's an example of a D flip-flop. So we have the keyword module and the module name. In this case, we chose flop. Again, that's, up to the designer's choice, the circuit designer's choice. And we have inputs clock and D. This is a 4-bit flip-flop or a 4-bit register, and the 4-bit output Q. And so this is the idiom that we use. We say always underscore FF. That always underscore FF indicates this should be a flip-flop. At pause edge clock. So this pause edge is the keyword saying at the positive edge or rising edge of clock, perform the statement. So at the positive edge of the clock, when clock rises from 0 to 1, then perform that statement, which is Q gets D. So D transfers over to Q. And so when we synthesize this HDL, we end up with exactly what we expect, a D flip-flop. We can also specify a resettable D flip-flop. So here, now in addition to our clock input, we add this reset input, and then we still have our D input and Q output. This part of the always statement is the same, always underscore FF at pause edge clock. So this will perform the statement within that always block whenever the positive edge of the clock occurs, whenever that event occurs. And what happens, this statement that it performs is now different. If reset, Q becomes 0. Otherwise, Q gets D as normal. When reset is 0, it acts like a regular D flip-flop. And so what kind of flip-flop or resettable flip-flop is this? Asynchronous or synchronous? Well, the reset only happens in response to the clock edge. So this is a synchronously resettable D flip-flop. So we could also build an asynchronously resettable flip-flop. To do that, we need to put the event that we want the statement to be evaluated on, or the event trigger, in the always statement. So always underscore FF at either, so it's going to evaluate the statement within that always block. This entire thing is called an always block. When either we get a positive edge of the clock or we get a positive edge of reset. So reset going high can trigger this evaluation. So if reset goes high, pause edge of reset, then it evaluates and says, hey, did I get, if reset is 1, it is, Q immediately resets and doesn't have to wait for the clock to rise. So this is an asynchronously resettable flip-flop. And from the synthesis, you can't tell the difference between asynchronous and synchronously resettable from the symbol. So you have to look at the SystemVerilog code. We can also specify a D flip-flop with an enable. So here's clock and reset has it's a resettable D flip-flop with an enable. So we have clock and reset as before, and now we add this enable input, and of course D input and Q output as well. And now we change it so that we have if reset, Q gets 0, so it becomes 0. Otherwise, if enable, then Q gets D. And we don't put the other statement because we don't need to. If for the statement, if none of those is the case, it just retains whatever it had. So it keeps holding the previous value of Q if the enable is 0. And now we have our synthesis of the D flip-flop with an enable. And is this an asynchronous reset? Yeah, still has the asynchronously resettable flip-flop with an enable. If you took this out, you could make it a synchronously resettable flip-flop with an enable. So let's talk about one other state element or sequential logic circuit that we actually won't use, and you generally don't use in your designs. In this class, if you produce a latch, it's an error. So latch, remember, is something that when the clock goes high, so when clock is 1, if clock, Q follows D or Q gets D. And so we use the keyword always underscore latch, and then if clock is high, Q gets D, and the else statement is just Q retains its value. And here is a picture of the symbol that's produced by the synthesis tool. And the issue is here, if you don't fully specify, for example, combinational logic, then you could produce a latch. And if you aren't expecting latches, which you shouldn't in this class, and you might see some warnings on the output of your synthesis tool that says, oh, warning, there's a latch produced. And you want to look at those and then fix and fully specify combinational logic is typically the problem with that. And I'll show an example of that momentarily. So again, if you're producing latches in your SystemVerilog code, there's an error.